So, sir, there is a one change.
Okay.
Actually, Dr. Kamal Jain is having some medical emergency with his mom. So he is with in hospital. So what we are going to do, one is our student, Shivam. Okay. So he will deliver a lecture how to start working on AI using Colab. So like you have to download the data. So where you are getting the data, how to process the data. So the basic initialization of the generative AI, deep learning using UAV images, satellite images. So that we can discuss today in this session. So I think Shivam, have you joined this session?
Yes,
Shivam.
sir.
Okay,
Uh,
Shivam. So please share your screen and
Sir,
yes,
before this, let me make him co-host.
yes,
Uh,
sir.
Shivam
Shivam
Dubey,
Dubey,
sir. Okay.
Mr. Shivam Dubey.
Shivam Dubey ji, Sushil sir, please make him co-host. Now, Shivam, you are able to share a screen.
Okay, sir.
Okay. Audience, please, as it is discussed here, there is a little change, and this session will be going to be very programmatical and very demonstrative. That's why it's a wonderful session going to be. Please, everyone, join it.
Uh, Sir, I have a one request with all the participants. If possible, please open your laptop and what steps he is going to start, do it accordingly. So it will help you how to start the AI in agriculture. Suppose you are not having a sufficient hardware. What in this lecture, what we are going to complete? Suppose a person who is not having a good skills in programming, he is not having a good skills in any other language, but he want to start something right now. He is having some data limitations, he is having some hardware limitations, because if you have to process the gps this agriculture UAV data or some satellite data, you require some high end GPU system. So there is another possibility. We have Google Colab GPU and TPU that we can use freely, so it is freely available. So I request to every participant, those who are interested to learn something new, they just open their laptop and follow the procedure which is given by the Shivam. Okay, Shivam, so you can start now.
Yes, sir.
Shivam, you are muted.
Yes, sir. I will start.
Yes, please.
जी.
So all participants are requested to, whosoever is interested in practical session, may open your laptop with internet connection and start the Google Colab as Shivam is going to answer it.
Sir, my screen is visible.
Yes, you are.
Okay, so today we will start learning basic Colab uh, functionality, how we can connect Colab with dataset, how to open what is Colab. So you can do this with me also.
Shivam, one my suggestion, if you are suppose you are opening something, a new link, just copy and paste in the chat box as well, so they can copy from there.
Yes, sir. Okay, so we will start with the Google Colab. So we just type Google Colab on Google. Welcome to Google Colab.
Copy this link in the chat box.
Okay, you can use this link to open Colab directly. So when you will open, you will find this kind of window where you will find new notebook, some examples, recent, some Google Drive, GitHub, and upload options. So in example, you can see overview of the Colab feature, markdown guide, charts in the Colab, external data, getting started with BigQD. All these uh, lectures are available. You can use in this in future also. So with the overview of Google, when you will open, you will open a notebook that is named as overview of collaboratory features. Okay, so let me give you some basic information about Google Colab. How you can access all the things. It will be difficult for you to understand if you are using first time. So you can open the Google Colab. When you will open, you will find somewhere to make new notebook. Use that tape this date file. You will get new notebook. So this is the file name. Every time it is come with untitled. So you can change this name as this is FDP program. So FDP. So here are some information how to add the cell, how to write code, how to write text in the code, how to run, and what the functionality Colab will provide us. So here you can see we are here. So in the options, you can see first file option where you can open notebook, upload notebook, new notebook in Drive, locate in Drive, then view, then insert. So this insert is important. We need to every time add cell uh, in our Colab notebook. So this is called the cell. So when you click on this code cell, it will add one cell. After one cell, you can use this when you came to the cell, you will find code and text option. Now, every time you can add cell from here, and this is the text. You have to write something, so you can write in this text box. And here is the option on the right side on Colab notebook. You will find connect option. When you will connect, connect it. It will show RAM and disk. This is the functionality that is provided by the Google Colab. And when you open this, connect, change runtime. So right now we are viewing resources. So what resources it is providing? So here it will provide you. It will, when you click on change runtime, you will see what Colab will provide with Python. And so it is providing CPU, that is normal preprocessing unit. And this is the important thing, T4 GPU. So as AI models are large, we need high computational. So Google Colab provides freely T4 GPU on the Google Colab platform, where you can use this T4 GPU program and the T4 GPU graphical processing unit. To save the GPU, is we have to run some AI models. The AI models, especially when we will work with large data and especially image data, we need GPU, high processing units. So it is freely available from the on the Google Colab. You can use. If you are using first time, you have to first create the account also in Google Colab. When you will open Google Colab, it will ask some permission. Please give all the permissions so you can do all these things. Now we will connect. Now we will learn how to connect the Google Drive to uh, Google Colab. So here you are on the left side. We can see many options like a table of content, replace, code snip. s- This file. So we have to click on this files. When we have click on this file, we you can find this upload option, then refresh option, then this third option, mount drive. This is the important part. So the height file. So we need to connect this. We need to mount the file. So when we mount the file, it will ask permission, connect to the Google file. Please continue with this, and it will connect it. If you are using first time, then it will give you some code. Google Drive mount something like you have to run that code. I will give you example. This code will be automatically generated if you are using first time. So here you can put this code and run this cell. So for running, you are having two or three ways. You can run all also, in which all the cells which are available are run. So it is also asking the permission. to give this permission connect to the Google Drive. This is asking signing with the Google. So allow this. Continue. So now you can see that this is like blue, green. So it indicates our cell is run. So you can run this from run here, from runtime, run all, from here, run all, from the cell also. This when you tape this will run. So I will open some codes which are available also which are available with me, and I will also teach you how to upload the file on Drive and how to mount the dataset from the Google Colab and run the code. So as I have working on this, so I have many files I have created. I will find some a small file which we can easily run. Or just wait, I will give you one file if possible.
Shivam, you are mute. If it is
Okay, sir. Sorry. ठीक है, sir. Okay, so you can run your. Okay, so we can connect the drive. After connecting drive, you can find the options drive. When you click on this, you will find my drive option. In my drive, you can see the files which are available on your uh, drive, Google Drive. So these are the files available on your drive. So the simple program which everyone writes. So we will start writing this with hello world and run. You can run this uh, from the shift or enter. You can run yourself with shift and enter. So just for example, I am using this notebook, Google Colab notebook. Uh, which has some files data frame. How in this we will see how to upload the data from the drive, and then process the data, and we will also learn download the data from Google Colab, Kaggle, sorry, download the data from Kaggle and upload the data on drive and use that data in Google Colab. So initially we will connect with the drive. The drive is already connected, and now you can start with this. You have to mount the drive first. Connect the Google Drive. Then when the drive is connected, here drive option is shown. This drive option is shown. So basically, it is the data set which we are going to mount is hardware Trojan detection data set, which are available online. We will see how to download and how to upload and use. Initially, I will show how to mount the drive. Mount the drive and use that dataset. So here are the basic libraries. We have to install from sklearn matrix, import classification report, confusion matrix, accuracy. From sklearn.matrix, import precision recall and F1 score. Then import libraries, import pandas, SPD, import numpys, np. Then all this. So here in this, we are using logistic regression, train split test, train test and split data. Then SBC, which is support vector classifier. Okay, so we will start running the file and running the cell, run the cell with control plus shift and enter. Then we will see how to mount the data, mount the drive and use the data. We have already learned how to mount the drive. So from here we will data frame we have written data frame as we are using pandas, so we need to create a data frame. So we are creating data frame here. In pd.read, our dataset is available in the CSV file. So we are using pd.read CSV, and these are the path which we are using. So what you need to do, you have to go in the drive, and from my drive you have to copy the path from your dataset. So we will use same dataset, so we don't need to change much in the program. So this is the dataset. Right click on the dataset. You will find copy path. Copy that path and paste the path into this cell. When you will do this, you will find this, and then you have to run the cell. So our file is now connected with the Google Colab. So you can see that your dataset here also data frame dot head. It will show you initial 5 entries of the dataset. So we can see that we have in our dataset 605 columns are available here. So these are the columns name, circuit name, number of primary input gate, number of primary output gate, something like. And then in this you are dropping some null values in your dataset, and then drop the last column which is circuit name. This column we are dropping because we have to give this data to machine learning models, and machine learning models work only on numerical data. Then check the type, then fill the null values with a main. Then we are dividing data into two in two parts, x and y. So x is the data set, and y is the target values. So what is the target values? So target values are labels 0 1 0 1 0 1 0 1 0 1. So we are keeping that labels into y files, and other which we have to train, or like they are not label, they are they that we are keeping in x. So in this you can run. So then scale the data. So we are scaling data from between 0 and 1. So run this. Now you can check the data also. So this is the values which are available in x, and you can check also y, the labels. Okay, so okay, this we are doing for x only. We are scaling data between 1 to 0 in here for x only. Then we have used PCA, principal component analysis. So principal component analysis is principal component analysis is a dimension reduction techniques, which used to reduce the data. In our case, we have 605 rows columns. So that 605 columns we are reducing 250 components. So these 250 components store all the important information from the data set. So we have applied the PCA and then transform data set. We can see how the original data set is 479 rows and 306 columns. So now we have 478 rows. Rows are same, but columns the number of columns are reduced. The columns are 250. Then print, and then we have print. Okay, then we will print the shape of training and testing data. So here we are splitting extend PCA, the data which we are just got from the PCA. X for train, X for test, Y data labels, train test. So we split and provide we are splitting data into 80 and 20. For testing, we are using 20% data in the random state. So we can print xtrain dot PCA dot shape xtrain. So we are printing the size. So here we can see the training data and testing data. So for training data set, we are using 382 rows, and for testing, we are using 96 rows. Then we have used random forest classifier. The output which we have got from the PCA, we are using that output into random forest. So here we have import the random forest from sklearn ensemble. So ensemble techniques. So random forest is an ensemble learning. Ensemble learning where the boosting and weighing process are there. So the random forest classifier is the boosting process where multiple trees are available in the random forest. Multiple decision trees are available. So decision trees are simple tree kind of architecture which decides in between 0 and 1, yes, no, yes, no, yes, no. But the problem with the decision tree is that the model can be overfit on the small data also. So generally people use a random forest classifier. It contains multiple random forest and then average. So here you can see we are using this n estimator 100 random for 100 decision trees we are using, and then we have train our model. So dot fit is used to train the model, then test that train model to the test set and print the accuracy classification report, confusion matrix, and all other things, all other parameters. So here we have run the random forest. You can see the accuracy. You can see precision, recall, F1 score, and support average, macro average, and weighted average for accuracy, precision, and recall. So this is the confusion matrix. So what our confusion matrix is said is we have 14 Trojans that are available, and 82 are non-Trojan things are available in non-Trojans data available in the file, which we have took for the test. So 4 out of 14 for Trojan, it classify all the Trojans that the model can classify all the Trojan correctly, and the misclassification of one that is in the in the non-Trojan. So here we can see confusion matrix. So actual 0, actual 1, predicted 1, predicted 0. So now we will learn how to download the dataset from Kaggle and use the dataset in Google Colab. So you can do this with me. So type Kaggle some crop recommendation dataset. So this is crop recommendation dataset. So we can download dataset from here. So the link is link I have shared with you. You can open your laptop also and see the dataset. And we have to download this dataset from here, crop recommendation.csv. So download the dataset. So we need to log in on Kaggle also. Those who are using, they need to log in with Kaggle. So we have downloaded the dataset, crop recommendation dataset. So that contains what are the fields are available in the dataset. N is the nitrogen ratio of nitrogen content in soil. P is the phosphorus content in the soil. K is the ratio of potassium content in soil. Temperature is the degree in Celsius. Humidity, pH values, and rainfall. All the columns are available in the dataset. So you can see this dataset also. Open. We can open. We have opened the dataset, and the columns we can see nitrogen, phosphorus, temperature, humidity, pH value, rainfall, and other level. So the data set is like this kind of data is nitrogen 19, phosphorus, and K is the rate for potassium. Okay, so K is the potassium. If the if in the soil or in the area nitrogen, potassium, phosphorus, temperature, humidity, and pH value are there, and rainfall is there like this, then the model should predict that you have to uh, form the rice. So now we will upload this dataset on Google Colab. First, we need to upload the dataset on Google Drive. Please open your Drive. Uh, so upload the dataset, new file, new folder. file upload, crop recommendation. So upload the file. So the file is uploaded. Please upload the file. Then we will open Google Colab. Open Google Colab, a new notebook. To connect the notebook with Google Drive. To connect the Google Drive with Google Colab. For easy way that you can also run the code, we will use code from the Colab, from the Colab. So we will crop recommendation ed crop recommendation. This code we will going to use. I will copy code from here to our Colab cell, then run that uh, cell, and you will learn how to give the path and all these things. So I will share this link also. You can also copy and run the code. Change this untitled .ipynb to FDP. The drive is connected. So for drive, go to my drive, and in my drive you will find that data which you have uploaded, crop recommendation data set. Now we will copy code from here. So you will easily copy and run the code. So first we are taking this import data. So we don't need this import OS and all this thing, because we are using file from our Google our drive. So we don't need this line, and you can use Kaggle also, where you have to run the code. You can do so. Import the NumPy and Pandas, run that cell, then copy all the necessary libraries and run. And then the important part is the data upload. Upload from drive. Where you can paste in, this is the simple way. So in path, the simple, you have to go in your drive. In drive, you have to go into my drive where we have uploaded the data. In this my drive data, you can search our file, crop recommendation, copy the path and paste this path into this path column, and then df. So this is the Python file. We are reading the Python file, but here we are using this path, and we are creating the same data frame as we have discussed. So run this file. Now you can print the dataset also. Print df. So you can see in columns NPK, temperature, humidity, pH, rainfall, and levels. Then print the five starting 5 entries of the data set. So you have to use df dot head. Then you can also print last entries of your data set. So use this tail command, df dot tail, and run. So this will show last 5 entries from your data set. So we have 2199 rows in the dataset and column. You can also print the shape. You can also print the shape of the data. So df dot shape. You can see here we have 2200 rows. So it is taking it is starting from the 0, and the 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. 8 columns including the labels. And the total size of the data, how many entries are available in the data. So this is the size of data, which is the simple multiplication of rows and columns. So here 2200 is multiplied with 8, and the end we can find the size of the data set. The size and not size, entries of the data set. Then we can print column also, df dot column. Print the columns. What are the columns? So index, as we already seen, N, P, K, temperature, humidity, pH, rainfall, and level are the columns here. In object, data type is object. Then we need to know the labels. What are the labels? How many labels are available in the data set? So we can use df label dot unique. Now when you will do unique, it will give only it will remove multiple names or multiple multiple crops. Means that crops data are coming multiple time in the labels, so it will give only one time that name. So df label is we can see in the data set, these are the unique labels are available: rice, maize, chickpea, I don't know, kidney beans, peas, and all this. The classes or the labels are available. So how many labels? One, two, three. So these are the labels are available. Then now we can find how many labels are available in the data set. So we can use n unique, number of unique. So here paste the code df label dot n unique. So here y 22 crops are available as a label. Now we need to now we want to know the values which are available, the labels which are available, how many they are, the count of the labels, whether the data are label or not. So we can use a value count. So label value count. So here you can see every crop is available 100 times. So the data is not imbalance. Everything is a balance. Then the data types of the columns which are present in the data set. So just paste this df.d types. So here all the data sets are available, and this is numerical, p numerical, integer, temperature float, humidity float, pH float, rainfall float, then label are the object. Then the information of the data, the how many null values are available for the different classes, different columns. So use this df.info. It will print the information of your data set. As range index 2200 entries are available, which started from 0 to 2199. Total columns are available is eight columns, and the null values is uh, nitrogen, no null values, phosphorus, no null values, potassium, no null values, temperature, humidity, pH, rainfall, and level. So the data is perfect. no null values, no imbalance data set. Everything is good. We don't need to do much pre-processing before applying this on machine learning model. Then we can also check that the null value are not available, but we can check the sum of the null values in every column. So df dot is null dot sum, some function we are using. It is taking time. Okay, so some intent. So we will use this call this null is the number of nulls which are present in the columns. Okay, so we have already run this. So this is we don't have any null values in the columns. Now the numeric values only. Then the produce the heat map. So this is the correlation matrix. So what this heat map shows, this heat map shows the relation between the columns. So this 74, that we can say phosphorus is strongly connected with the potassium, and potassium is same, and this minus values that nitrogen is not good connected with the potassium. So these red kind of thing, red or orange, this orange indicates the highly connection. The minus shows the negative, not connected, not having good relation between the variables. So these are the correlation matrix. Then we will divide into target and labels. So these, as we have divided in the previously x train x and y, here same we are doing. Just we are putting all the features into all the columns features which are important, and we have to train the model in features, and and their corresponding labels are into the target. So run this. So you can check target and values to you can print all the values in this. Then initializing a list to append all models name and corresponding name. initialize this. We are doing same that the given in the collab Kaggle. So then import learn model selection for training, testing, and validation. So here they are doing training and testing only. So the test size they are taking is 20% of the data, 0.2 targets and features. Copy this code and run. Then they are using decision model. So we will also use this decision tree model. So copy this model. First, they are importing the decision tree model, then making decision model, then fit that model, fit the training and testing, fit the model for training, then test that trained model and predict the values and append the accuracy in the accuracy list. So copy the code and run. So run this code. So the decision tree giving accuracy 86.53%. So here class wise accuracy you can see apple, banana, all the class. So in some lentil class are having low precision in abundance code. And jute are, but the model is failed to detect the kidney beans. Then they are doing cross validation score. So finding for the average accuracy, they are doing cross validation score, finding the cross validation score, and from using this, they will find. So copy this code and run. So cross validation score is not defined. Okay. Okay. Uh, Please don't forget to import the cross validation score. So this is the average accuracy is 92 point. And they have saved the decision tree model. Then we will test other model also. Gaussian Knight based model are also available. Here they have also tested. So we will test on this model also. So please copy the code and don't forget to import Gaussian Naive and create the model. Then fit for training the model. Then predict and test your model. So copy this. Okay, so internet connection is fluctuating here. Okay, this okay, this file we are using. Sorry. So paste this naive code also here. and run this code. So the naive Bayes is performing better than the decision tree. So it only Jute class having having problem, or we cannot say problem, or the one instance it is not uh, correctly identified. Otherwise it is identify everything correctly. And then same they are using support vector also. So support vector machine we will use. Okay, so they have used many models. We will use and do the accuracy comparison also. So now we will use SVM classifier import, then make the model, then fit for training the model, then predict the values for on test case. Run this. Okay, so SVM giving accuracy is 90. It is not able to read this class, and also failed to read the orange papaya. Pigeon peas, rice also not detected. So the accuracy is not 90, it's 9%. Because the model is failed to read 5 to 6 classes. So the model is not learning. Then logistic regression. Then they've used logistic regression. Please copy the code, make the model. Copy this code, run the code. The logistic regression code is also done. Make the model test. So it is giving 94% class accuracy. Then they have used random forest also. Copy. The random forest is providing 99.31% accuracy. So the random forest is much better than the decision tree. Then they have used XGBoost also. So we did not use label encoder. So we have to for running this we have to use this also. Otherwise we need to write code. Then you make the model and run this model. It is also giving 90. 98% accuracy. Then the accuracy comparison. And after that, they have printed the graph for the comparison, for the accuracy comparison. This is the graph where we can see that naive Bayes random forest XGBoost achieves good performance. So this is the basic things we have to today we have to learn. We have did Google introduction of Google Colab, how to use Google Colab, how to upload file on Drive and connect that Drive to Google Colab. Again, then I use the dataset from from Drive into Google Colab and run some sales like we have created some models. We have not created the models are already available. We have used that models to run in Google Colab. So the links I have shared with you, you can use that model also.
So Shivam, it is over from you.
Yes, sir.
Okay, Shivamji. Thank you, Shivam. It was really a wonderful session on Colab. The way you explained the working on Colab is fruitful to every academician researcher. Your clear explanation and hands-on approach made the concept much easier to understand. We truly appreciate your effort that you put in preparing and delivering this session. Thank you, Shivam, once again.
Thank you, sir.
Okay, now Deepanjali madam. Deepanjali madam.
Sir, my camera is disabled.
Okay, so no issue. Okay, I just continue it. No issue.
No, I'll do it. Good evening, everyone. I hope you're all enjoying the session so far. Now we will move forward with our next session. It is my absolute pleasure to introduce and invite Mr. Vishal Sahare, founder and generative AI architect at TCS Pune, to deliver his talk on refined computer architecture for AI and ML applications. I am Dipanjali Dhanuk, and I am honored to welcome Mr. Vishal Sahare, a highly respected AI and data science leader with over 14 years of experience in designing, architecting, and developing advanced AI, ML, and generative solutions. His expertise spans a variety of industries, including retail, insurance, banking, and finance, where he has consequently created scalable enterprise level AI architectures that have driven transformative business outcomes. Mr. Sahare's deep knowledge of generative AI, machine learning, deep learning, and natural language processing has made him a sought after expert in the ever evolving AI landscape. Throughout his career, he has successfully led cross functional teams in Fortune 500 companies, implementing end-to-end AI solutions that boost operational efficiency and enhance business intelligence. He also specializes in cloud architecture using platforms like Microsoft Azure and Databricks, and has extensive experience in AI infrastructure design, model development, data pipelines, and real time analysis. Now I'm excited to hand over the floor to our esteemed speaker, Mr. Vishal Sihare. The stage is yours, sir.
Thank you, Dipanjali.
You're
I'm
welcome,
audible.
sir.
I'm audible
Yes.
here. Right? Okay, perfect. Let me share my screen quickly. Let me know if you are able to see the PPT.
Yeah, sir, it is visible.
Okay, perfect. Thank you. Okay, so let me start. So today, so this is the continuation from what yesterday we have discussed. This is a second session for me. So what I'll do, I'll start with today's topic, which is redefining compute architecture for AI and ML applications. And then I'll connect the dots, which we have left yesterday. The approach for today will be like, I'll complete focus towards starting 20 minutes for these compute capabilities for architecture design and leveraging it for training, inferencing, and processing of data in terms of refinement and the data engineering aspect, in feature engineering aspect, inferencing side and all, right? And post that 20 minutes, I will take your times for architecture walkthrough, which yesterday I have left. I'll connect those all the dots which yesterday we have discussed and what today I'm going to discuss in a real-time implementation, what I have did for few of our retail industry. And I have created one architecture for yesterday's topic, that is a farming related use case. Post that, I'm going to cover next 20 to 30 minutes for what kind of frameworks we are seeing in an industry. So I have created one Databricks free, kind of edition. So it is having limited capability, but I can just try to, mimic those all things with the enterprise grade of subscription. With these all, I'll open the floor for Q&A. But in between also we will discuss. I'll open something 5 to 10 minutes, kind of floor for Q&A for each topic cover. So let me start. So today agenda, it will be like how these computing is progressing with time in AI world, right? We do start with CPU and then specialized hardware which we are using when the data size, when the latency requirement is high. Here I will share some use cases which in real-time implementation we will encounter, and how what will be our approach to fix those, right? Post that, I will talk about what all the varieties we do have in terms of processing unit. Like CPU, we already knows. GPU, what it is, how it is work, how it is helping us for faster processing. TPU, what it is, what is the comparison amongst these all CPU, GPU, and TPUs, right? And post that, a memory and IO architecture I will talk, and then system design when we are building production grade AI applications, Gen AI applications, right? Then what is our methodologies for system design, right? And at the end, I will just talk about some variations like, okay, what is on-premises things? What is the cloud-based solutioning, right? What is the hybrid, which is a mix of cloud and on-premises? Now I do start with the AI compute advancing with time. so as we all know, right, like CPU is one of the core when we started using our desktop-based computers or laptops, right? And even with server grade systems, CPU is one of the core unit for processing. Okay, there is some issues with it. Even we are having multi-threading and multi-processing for CPU enablement. But as you can see, and if you understand, there are three main components whenever we are talking about any application or when we are talking about the computer, right? One is processing unit, which is definitely CPU in our case, the RAM, and there is a storage. And connectivity amongst these three components we are enabling with help of bus, which is kind of connectivity maps towards these all with motherboards and all, right? So with CPU, the challenge is like first thing, even we do have something around 100, 200, 300 cores, right, for CPU. The RAM is one dedicated part where when we are reading the data, we are processing the data. It is reading, writing amongst the RAM and the storage, right? So time is very critical when we are talking about the latencies and the production rate system. So the outcomes when the processing is happening, right, that is huge. So that is what the latency, right? So to overcome this, GPU comes to the picture. NVIDIA is one of the biggest vendor in this field, right? And what GPU is doing, GPU is having its own kind of architecture, which is far better with CPU. Parallel processing capability it is providing, and memory also it is having inside. So when we are talking and when we are purchasing the laptops, right, we are not seeing, okay, CPU is having 6 GB or 10 GB. But when we are purchasing it, GPU, right, we are seeing, okay, it is 4 GB RAM GPU or 6 GB RAM GPU, right? Because that architecture is bring the temporary ROM, right, inside the same hardware piece, right? That is what the GPU, and that's why parallel processing is happening. But to enable this parallel processing, we have to do a CUDA enablement, and we are having Rapids library, which is helping to leverage this GPU capability. So just assume you all, I think, aware of the Pandas, right, which is a Python library to read the data. It is kind of a tabular structure kind of processing it is helping and all, right? So if we my complete program is written on the Pandas, right, or Python Pandas, NumPy and all, right, then directly it is not able to integrate with the GPU and not able to capable enough to handle leverage the GPU capability or power. So what we have to do, we have to refactor this code. So for all individual components, so I will take 3 examples in the library which Python provides, and it is compatible with CPU but not compatible with GPU. Okay, one is Python's Pandas library. Second one is NumPy, and third one is very famous sklearn, which is machine learning data scientists, engineers are leveraging and using, right? So when our program is written with these 3 aspects, it is directly cannot be used GPU. Okay, but when we refactor it, so Rapids is the one library which is giving one-to-one mapping against these all libraries. So for Pandas, there are cuPD. Okay, there for NumPy process, NumPy related functionality enablement, there is cuPy. For scikit-learn machine learning models, which is coming from scikit-learn library, right? Like you had heard the name KNN. There is logistic regression. There is random forest, right? Decision tree and all. So these are libraries scikit-learn provides. So the similar kind of capability for GPU training or GPU compatibility, there are QML that library is providing. And code-wise, syntax-wise, is similar. Okay, so that refactoring we have to do to leverage the CPU, and the similar kind of refactoring we need for TPU kind of processing, which we will learn in the next section. Okay. Now, as I said, like CPU to GPU to specialized hardware. So there are three aspects nowadays we are segregating: CPU, GPU, which we have discussed, and there is a specialized hardware where there is a TPUs, Trainium servers and all, right? So as I said, for GPU, one is the one library is Rapids. But how Rapid is going to leverage the GPU? So for that, CUDA enablement is required, right? And in production grade system, we are not having only single GPU. We have to create a cluster of GPUs, and that cluster will help of Dask clustering. So there is a Dask library which we have to use, which is having a library like Dask CUDA. And then on top of that, all the CPUs, right, in production grade system are going to interconnect it. And that is what giving a boost to our training and inferencing. So in real world, we do have petabyte of data. So just, my one of the retail use case where a Flipkart kind of company for I'm working in US, there, any particular point of time, there is something around 1 million to 1.5 million customers are, doing shopping. Okay. And when data generation will happen with these 1 to 1.5 millions of users is something around 1 terabytes. Okay. In 24 hours. So that scale we have to, analyze. So for that, GPU is important. Okay. As I said, like CUDA codes we do have in GPUs, and for that enablement, we have to use Rapids library, and then refactoring is required. There are memory side hierarchies also there, where VRAM and L1, L2 cache are there, and there is interconnection. So the normal bus, which is taking our data inside our these all three components, major components. So for that, it is a high, scale buses we are using. That is, we are saying NV lines, right? For connectivity and syncing those multi GPU kind of architectures. Okay. And metrics exploration is very important in GenAI and this machine learning, because whatever the neural network we do have, right, which is based on top of that, LLMs are based, right? Those all tensor kind of metrics calculation it is doing to learn the patterns, right? So for that, these metrics acceleration is required, and there also the GPU helps a lot. So as I said, like 900 GB per second, that kind of capability we will get for our data analysis when we are using GPUs. Now comes to the TPU, which is another advancement on the GPU. But here some drawbacks also. So let me focus towards the advantages. So like for GPU enablement, we have to do a lot of refactoring, CUDA enablement programming we need to know, right? But in the TPU case, that is a bit easy. But when we are using the same kind of capability, right, then costing is high for TPUs. Right, but it is energy efficient. So nowadays you had heard like what is Intel, another one is another processor, right, which is having more efficient in terms of energy and all, right? So that kind of comparison you can do with GPU and TPU. So let's this is what the head-to-head comparison I can say amongst the GPU and TPU. And in some aspects GPU is good, some aspects TPU is good. But when we are doing our operationalization for any models, right, or solutioning deployment in part of inferencing, we generally choose based on the criticality of the business. So when we are doing any project with latency, we have to think for cost also. So there is a latency cost trade-off. Okay, if one thing I want to improve, another thing is going to decrease, right? Or vice versa. So that trade-off always we have to maintain. And that decision point comes with help of business metrics and business approval, basically, right? So ROI, there is a return investment. Okay, so that also we have to be keep in mind when we are designing our architecture and we are picking the components. So for us, processing part is just one component with other component which we have to balance. Then memory and IO challenges. So as I said, like, cache, and then so here I want to be discuss one use case. So just assume you are having something around 250 GB of data, okay, and this is one big file. You want to just do a POC in your laptop or enterprise grade some cheap server, and how max RAM you can increase? Something around 64 GB, something around 100 GB. If just assume the data is not 240 GB, it is 1 TB, then how you can read the complete data? So there are strategies which we have to be used here, right? So can someone answer me this? If 1 TB of data you do have in a file and you are having something around 128 GB of RAM with something around 100 cores of CPUs, how you can process these data? How you can read it data? If you will read, what will happen? In audience, anyone can think for this? How we can approach for this processing? Okay, when we will try it, right? What error we will get? Okay, so let me explain the solution approach for this. Okay, first thing is, when we will try to read these data, 1 TB of data with 128 GB of RAM with hundreds or 200s or cores of CPUs, then out of memory issue it does come. Just assume we are reading it with pandas, right? Because it is trying to load 1 TB of data, but there is no sufficient RAM available. So where it is going to sit? So for that, on that scenarios, what we have to do? We have to use a Dask library. What it will do? It will read on chunk. It will maintain the consistency, right? So just assume 124 GB of data. So it will it will segregate complete 1 TB with those 12 parts of 100 GB, and it will load one by one. And whatever the results are there are consistency it is going to maintain with results consistency and processing consistency, and that way it is going to proceed further, right? Now, when we are reading it and processing it, right, then because hundreds cores are there, but our programmatical way also we have to be tell to our computer, okay, my program is capable to handle those 100 cores. So multi-threading comes to the picture, right? There is another variance which is multi-processing, which we have to leverage when multiple CPU with 100 cores are available, right? Which is a kind of a cluster, right? CPU clusters. So those all methodologies we have to use when we are developing our solution, designing our solution, and when we are deploying our solution in production grade systems. Now, system architecture, right? So here again, a very important concept comes. When we are designing our solution, whatever data is there, it is present in their databases. So just assume Flipkart. So Flipkart is having multiple, data sources. They are using ERPs. They are using CRM systems. So ERP is nothing but enterprise relationship management system. There are CRM system, that is a custom relationship management system. There are inventory optimization systems too. There are supply chain systems. They are having their a custom application for that Oracle database or DB2 database or any other databases are there. So that is what the first point of data sourcing. Okay, so when we are doing as any solution building, when we are doing that, right, data analysis, then this is one of the critical part which we have to be think for. So there are these data. Now this data is coming from these all sources to Delta Lake. which is present inside if it is Azure, then ADLS Gen 2, which is Azure Data Lake Generation 2, where it is come. That is our data warehouse. So what is my RDBMS? That is SAP HANA database or Oracle database or any XYZ RDBMS database, right? What is my data warehouse, which is OLAP kind of architecture based system? That is my ADLS Gen 2. So bringing those data to these data warehouse, there are processing unit comes to the picture. So in Azure case, there is Azure Data Factory, which is connecting with these multiple sources and dumping the data on this ADLS Gen 2, which is my data warehouse, and it is using OLTP. These extract, load, and transform, ELT based concepts basically, right? So processing this complete data required the processing power, and the processing power comes from the CPU, GPU, or TPU, right? So there is another. So see, GPU and TPU is very price sensitive. So what we are doing generally, the CPU only we are using, but we are not going with Python. We are using PySpark, which is Hadoop based concept, and designed and developed by the database community. And this PySpark is kind of advancement on the Python language, and for compute CPU only it is consuming, but Spark clusters. So CPU with Spark clusters. So there is another wrapper what they are using, and they are leveraging these all CPUs as a cluster. And these cluster understanding, which we are saying Spark compute clusters, right? The Spark-based, Python Spark-based programming we have to do to process this complete data from this RDBMS system to data warehouse. So that all complete flow is happening. Okay, so that is one phase. Now data is present on our data warehouse. Now the machine learning or GenAI engineer or developer or data scientist work starts. So that what we are doing, we are reading those data from these data warehouse, okay, and we are crafting the features so that machine learning models consume those features and give a correct predictions. So for training also, again, the CPU, GPU, and TPU is required. So there are two major concepts. One is batch training, and another one is real-time training for machine learning models. So again, I am taking reference of Flipkart. So see, some recommendations mails we are getting after 24 hours. So whatever activities today I am doing in Flipkart, based on that, next day after 24 hours or after 2 days or 3 days, the recommendation is coming. Okay, you are searching mobile. So this is what the another competitor mobile brands which you can think for, or supplementary things, right? Okay, you are purchase mobile, so go with this case and this charger for it, right? So that kind of recommendation we are getting after 24 hours. So that is a batch processing. Batch training is happening, and based on that, this recommendation are coming. But some cases very real time, near real time recommendation are coming. I'm in only the website, I'm searching something, and the same time I'm getting pop-up. Okay, go with this alternative brand, go with this cache, go with this screen guard, right? So that is near real time recommendation are coming. So two pipelines we are building for training also. One is batch pipeline, another one is real time pipeline. So yesterday one question was asked, how real time pipeline and how real time data is going to flow. So when I will just jump in on the architecture, I will explain all the components, what is the complete process it is. Okay, so that is what I am saying training. Now inferencing, once training is done, now model knows what is the pattern, what is the learning on top of the data, right? Now model must have to be ready to serve to business. Okay, so just assume training is happened with 7 days of data, or 3 years of data. On top of that, incremental training we are doing generally. Always we are not training on top of 3 year, 4 year, 10 year of data. We are segregating towards the phases. For first phase, definitely complete data, then incremental training we are doing generally. And for that training, all the learnings has been done. Now, whatever in these 24 hours recommendation is happening, batch pipeline and batch training, it is consuming on that, and that inferences pipeline are processing that. So again, the CPU is required, right? So I explained data processing side. When ETL is happening, the compute is required. When training is happening, compute is required. Then feature crafting is happening, compute is required. And when inferencing, when model is ready to serve, right, that time also inference, this compute is required, right? And when we are choosing the compute, either CPU, GPU, or TPU, or cluster of Spark, we have to be choose. That is depends in which phase we are and what critical latency we do have, right? That way we are balancing our processing time and the cost which involved for this complete process. Okay, so this is what I'm want to cover as part of this slide. Now the TPU. So TPU is again one of the very kind of important part nowadays, and with time it is competing towards the GPU pricing with advantages like carbon footprint. It is reducing. So government agencies and all, they are focusing towards it. Okay, use the TPU instead of GPU. You cannot believe when I was visited Tata Dadar center for data center. It was so cooling those all CPU. It is something around a big college size of campus where all the clusters, CPUs, storage was there, and to cooling it, a huge amount of a huge liter of amount of water is required, right? So that is what the wastage of water. So if energy or cooling is controlled, which TPU provides on top of GPU, then definitely TPU is a good choice if it is bring down its cost compared to the GPU. Okay. So it's too much for the CPU, GPU, TPU. Okay, I think you guys will feel bored. So now we will switch our topic towards the cloud, on-premises, and hybrid kind of solution. Okay, so here these concepts comes to the picture. Okay, till here any questions? Sorry to ask.
Audience, if you have any question, please put in the chat box, or you can raise your hand.
So silence is always yes.
Yes.
Okay. In IT industry, and if there is no silence, it means no in I think your educational field, right? Okay. So we'll proceed further then. These three concepts: cloud, on-premises, and hybrid. When and how we are going to decide which framework we have to consider, right? So see, when pre-cloud era, what's happening? When any project is starting, we have to provision our hardware, right? We have to go to the IT team. There are one negotiator is there who is dealing with Dell and HP and all, and ordering them, and then hardware comes where IT engineer, system engineer assembling it and making ready. It is a time consuming task, right? That is what the on premises, but it not means completely on premises went out. Okay, but this is what the issue is. Now what cloud is saying, hey guys, you don't worry, I do have near infinite kind of compute, storage, and these all components. You just use it, and for whatever you are using, for that only you pay. And the very good thing is there is no kind of delay in terms of procure the infrastructure, making ready the infrastructure, right? So they do have data center this data center in their different location, which is abstracted for us. Just one console we will see, that's it. I will show you the console, how it's look like and all. But we can directly go, we can do a spot kind of, ordering for that. And within 5 minutes, it is going to pop up with complete infrastructure, which includes networking, which includes all prerequisite operating system, which includes RAM, storage and all. Okay. And the second good thing is it is a horizontally scaled. So just assume in middle of application development, before you have procured something around 5 CPUs and 1 GPU and something around 1 TB of storage, right? But after 2 months, you feel okay, some additional resourcing we need. So you can quickly, add it on your infra, right? So that fast it is, and that advanced it is, right? And there is no different roles are required. As a architect, I can do it. As a developer, another person can do it. Okay, if he is having capability to understand those all concepts. Okay, so this is what the cloud, benefits are. On-premises benefits, I said, like, okay, I didn't discuss about that. But many of the companies don't want to disclose their data on cloud, because they assume that cloud is going to control by some XYZ team, some vendor team. In Microsoft case, Microsoft engineers are handling it. Microsoft also giving the contract to third-party vendors. So that kind of things are there, so that they are not comfortable with. And those sensitive data is inside their on-premises servers. Okay, so all financial companies, all high sensitive healthcare companies, right? Those all keeping those data in on-premises. But it not means cloud is unable to do it. There are abuse monitoring for any resource which we can request to Microsoft, Google, or AWS, and they will, once they will enable it, then they will say we are not going to monitor anything at all for this specific component. So that things can be enabled, but still we are human beings, right? So we are not trusting on it. So this is what the on-premises. Now hybrid, when the combination is happening, okay, some sensitive application is not there, so we will take benefit from cloud, and some sensitive kind of data is there, then we will use on premises data. And the combination of on premises and cloud is known as a hybrid solution. Okay, so again, time limit, already 30 minutes I passed. So let me now speed up from here. Enterprise AI architecture layer. These layers we will discuss in detail in pictorial representation as part of my architecture design. But for just sake of understanding, high level understanding, business architecture there is where business and senior stakeholders for that application development, like product owner, architects, those all are sitting with the business COEs and CTOs and head of those specific domain. And we are deciding, okay, what kind of requirement it is, what competitors are having, those competitor features, application, how we are going to develop for our organization. So those all kind of discussion is happening as part of business architecture kind of discussions. Okay, those architecture now going to map towards the architects. So data architect. So there are many roles in the architect fields too, like data architect, Gen AI and AI architects, infrastructure architect, integration architects, right? So those all security architect and all, right? So those all roles has been defined. So we all architects sit together, will understand all the requirements, and based on that, we are going ahead with our solution design. Then application architecture. So as I said, multiple architects layers are there, right? So all architects is responsible for their core areas. So if data architects are there, they will think for data related, consumption, refinement, ETL process, transformation and all. Right, when application architect comes to the picture, he will think for how this application is going to talk with each other, right? So there are microservice concept, there are API designing and integration and data contract kind of concepts comes to the picture. ML service orchestration. So as a Gen AI and AI architects, we have to take care of that, right? So, but these all architects means primary skill is definitely their core area, but they knows in high level as part of secondary skill their other architects responsibilities. So in my case, right, in Gen AI or AI architect, I know, okay, how AI layer look like, but I know how data side it look like, how the integration will happen, how the infrastructure is look like. So as a secondary skills, we have to be aligned with those component understanding and integration understanding, right? Then technology architects, as I said, this is a different name, but generally in the industry we are saying infrastructure architect to these guys. And again, these all architects is having vendor specific architecting capabilities, right? So Azure data architect, Azure AI architect, Azure infrastructure architect, Google infrastructure architect, and vice versa, right? For other clouds too. And what benefit we will get with the architecture principles are modularity. So before, if you had seen in 2009 and 10, when I was passed out, just 3 layers, right? Data layer, middleware, and database layer. But that is tightly coupled. When some specific functionalities we want to develop, we have to wait for complete layer development. But nowadays we are following the microservice-based architecture and API-driven architecture. So it does not matter till what extent and what complex some specific functionality is. We are rolling up with the individual functionalities and we are making live to it. So this is what the hardware optimization we have discussed, right? Latency and the throughput. So latency, when we are thinking for, there is a different strategies we are using. So if you are aware, these Llama 3 and GPT 4o, right? GPT 5, with time, their size is very huge, like, something around say 7 TBs till 7 TBs and all, right? So when the size is more, knowledge base is more, when we are requesting some answers or some analytics, the response is very slow. So to reduce it, we have to quantize it. Okay, so there is a PEFT and QLoRa kind of techniques we are going to use to reduce the size. So quantization is reducing that 7 TB of size to the GBs, right? So that way, definitely we have to compromise with our performance, but latency is very high. So the very, kind of medium complexity task we can take from these quantized models, and whatever very critical task, right, we are taking it from the master models, which is actual trained with 7 TB and all, right? Now, LLM Foundation, yesterday we discussed in detail, RAG pipeline. So whatever the chatbot you are seeing for any specific organization which is capable enough to respond for those organization specific question and answer, that is, built on top of RAG architecture. So RAG is nothing but augmentation, right? And here one different variety is coming for the database, that is a vector database. So that vector database is index-based embedding database. So, what the difference, if I will ask, right? Ki RDBMS, like Oracle, right? Database and vector database, what is the difference? So difference is in RDBMS, we are having SQL queries, select star from something, right? Which we are executing and we are getting the outcomes. But in the vector database, we can simply write in our normal language, which is going to convert on embedding. And then in vector database, all the knowledge base is stored as a embedding, and there is cosine similarity, MMR kind of techniques are there, re-indexing and all is there, researching and all is there, which is capable enough to understand the human language and giving the response. So it is easy now, right? So always we are saying no need for SQL understanding, right? Just write in your language, the database could understand your interaction. Agentic AI, yesterday we have talked a lot. Today again, I will talk in the architecture. Observability and governance, right? So this is one of the critical topic yesterday we was discussing. Trust, right? Can we trust in the AI? Can AI can surpass the human intelligence? Yes, it is. And this is all the, the architecture we are going to leverage for our solutioning, so that if something AI is fluctuating towards the objectives, can be controlled. So hallucination, there are observability, interpretability, there are faithfulness, right? Those all things we are going to control with help of these architectures. If I will talk about the future, what is the future? So this is what I am thinking as of now. So definitely till now we are, as a programmer or as a AI guy, we are giving instruction as software how the GPU is or CPU or TPU is going to leverage. But near future, we can create a specialized agent which is able to write the code, which is dynamically change the code based on the availability, right? And then it is going to fast track all the processing. So nowadays, how we are achieving it? We are having fallback capability. So if just assume I do 100 CPUs and I'm having cluster of 100 GPU, and my code primarily is very high demand code with low latency. So I'm running it on the GPU, right? But what about 100 CPU? Because that is ideal now, right? So how I am going to leverage? So we are having fallback kind of dynamic programming we are making, so that if once the GPU is going to consume completely, just fall back with the CPU processing. That way, CPU and GPU both world we are using for our compute capability. Okay. Yeah. Key takeaways. These all things we have gone through, and question and answers. So team, again, it's open for Q&A. If any specific point you want to discuss, please let me know.
So there's a
Yeah,
question in the chat from Anju Singh. When we build generative AI projects in Python using VS Code, at what point do we need a GPU or TPU? How do the two differ in terms of performance, and what setup or best practices would you recommend for developers who want to use these accelerators efficiently?
Okay, so let me quickly show you in real time how we are using VS Code and how the things is going there. So this is my VS Code, okay? And here, if I will not integrate it with any clusters, right, which is a cloud-based clusters, it will take my local laptop CPU, okay? And if I am having GPU, it will take a GPU based on the refactory, which I have explained in detail, right? But if I want to use cloud cluster, okay, so let me quickly show you the cloud also. So this is the Databricks, okay? So Databricks is nothing but a framework, okay? So in AWS, in Azure, and Google, these Databricks, present as a individual component for all the clouds, okay? So that way it is saving us for vendor locking, okay? So this is Databricks. In these Databricks, if you will go with compute, right? So this is a free trial. So I'm not seeing other variants. So there are TPU, there are GPU section, there are Spark cluster section and all that I can create. Now I want to use these cloud Databricks GPU or TPU. How I can do it? I just go to extension, okay? Here I will see Databricks, right? This came, and now I have to install it. Once I will install it, so in my system it's already installed because I'm using it. I'll see here, you will see install option. Once I will install it, it will ask for credential, and it will be map your local VS Code with the compute. So this is one question, how we can use it, right? Now, when we have to use CPU, GPU, and TPU, as I said, when you are doing some POCs, definitely POC means prototype of concept, okay? So that time it is just a kind of, in a very low data, just showing that, okay, my concept is working in a real time, right? So that kind of scenarios, we have to use CPU. When we are doing a production grade system where CPU is taking 10 minutes, 1 hour, 2 hour, 3 hour, so we cannot wait till that point of time, right? So on that cases, CPU and TPU, we have to use any of them based on the optimization and latency trade-off, which I have discussed in session, right? So this is what the methodology and strategy should be. Hope I have answered this. Any other questions? Dipanjali, you are in mute.
Madam, unmute first. Please,
Okay,
sir,
sir,
can
no-
you read?
Yes, Vishal sir.
Yeah.
A question is asked here. Please tell me about the PySpark, which you said one of your suggestions.
So a PySpark is, what it is, just think as distributed programming. Okay. So a few years back, approx 7 to 10 years back, we are always listening big data, Hadoop, right? Nowadays it is GenAI is a buzzword, but that time 2016-17, big data and Hadoop is buzzword, right? Zookeeper, there is different Hive and all, right? That kind of component was there. So
Yes.
that is what the where from these PySpark has been, came to the picture. So PySpark, what it is doing, it is kind of a Spark compatible language which is supporting distributed computing. Okay, so in your college you do have you are having lab, definitely there are 500 to 1000 computers are there with CPU enabled, right? So anyone can take an initiative and just create a cluster for Hadoop. Okay, and then you can enable high scale PySpark application and leverage all the CPUs whatever are present in your college. Okay, so if I will go with Python, that is single instance compute kind of capability. But when PySpark, it is a distributed computing which is giving instruction for computer that, okay, if you are having available whatever amount of clusters, which is just a group of CPUs, right? Just take this framework, which is PySpark language, and process all the things in parallel, right? So it is just a variance and advancement on the Python. If you know Python, then PySpark is easy. Okay, so don't worry, you will just jump with the PySpark. Okay, start with Python and then gradually groom with PySpark. With fresher level, with even 10 years of experience, nobody is expecting PySpark. Okay, when I'm also taking interviews, I'm not asking questions from PySpark because I know this is an advanced topic, should be concentrated towards the Python. If the person knows Python, I can groom him with 1 to 2 months training with PySpark.
Good.
Okay.
Okay. Sir,
Okay.
one more question is here. For running large scale data sets, minimum configuration should be what?
Minimum configuration is your CPU. If you are ready to wait for 1 hour, 2 hour, 3 hour, 10 hours, there is Python which is able to handle these things with Dask library. You just search for Dask, Python Dask support, and multi-threading with multi-processing capability. Okay, but you have to wait definitely, right? 10 hours, 20 hours. So don't go with the large scale data. Just sample it with something around 10 GB, 20 GB, for which the Python is suitable. Do your POC, your work, your proof of concept, and then show it to your organization or your research holding body, and then upscale it with MVP, and then finally with production grade.
Okay. Thank you, sir. Audience, any other questions?
Okay, silence
Okay.
means no.
There's a
Okay.
question in the
Okay.
chat box.
Yeah, Dipanjali.
What are the limitations of today's Gen AI models?
Sorry, can you repeat the
What are the
question? Your voice
limitations
is
of
breaking.
today's Gen AI models and which ones are the hardest to solve?
Okay, so I can say no limitations.
Sure, sir. What are the limitations? Am I audible?
Yeah, you are audible, Dipanjali. So my response is no limitations. You are, if you are having a good engineers, good architects, right, good
No
developers, then
limitations.
no limitations.
Can you explain it, sir?
Yeah, definitely.
Because
So
there is always a limitation.
yeah, so yeah, that is limitation for those who is not knowing it in depth, right? But we are in via the Chandrayaan, we are controlling from the Earth, right? There is no limitation. Okay, and with time,
Yes,
again,
sir.
it will be cheaper, right? So I want to give an example with my own experience. Definitely Chandrayaan example I have given, which is capable enough to understand in which orbit, which space, which place it is need to be land. From here only, within seconds, we are controlling the Chandrayaans, right? Or similar kind of satellites. And this all is happening with AI. Okay. So definitely there is no limitations. If you have gone through the researcher who had did his complete life with research for the DNA analysis. Now Google one model has solved it within 24 hours. So his whole life, 30 to 40 years, with group of scientists who did the research in healthcare, the Google model has been solved the same puzzles with additional 3 to 4 approach within 48 hours, right? So definitely there is no limitation. The limitation with us as a human being, we are not able to capable enough to leverage all the capabilities for the same. Okay. So now coming to my example, which I learned with the industry. Nowadays, I'm doing on one POC where data engineers, senior data engineers are writing and cleaning the data. Okay. And a human intelligence is required to write a logic. Basically, it cannot be solvable with any combination of Python programming or any programming. Why it is? The data is in Excel. It is having multiple headers. In very places it has broken. So in multiple seats it is. So anyhow, we have to be reviewed via the human eyes. We have to visually understand. We have to manually create another seat, which we are saying refined seat, and put the data organized way, which rule-based Python programming or any complex programming can be solved. And this problem with this client from last means till whatever time he was. Okay, I have jumped in. They have given the problem as a POC, and I use the GenAI to understand what as a human I could understand, right? And that has been solved within 2 months. Okay, so whatever a human can think for, the same thing can be enabled with AI. Definitely, approx 2 to 3 years back, there is governance issue, there is a trust issue, there is a fairness issue. But now these frameworks, right, which we are considering as a ethical AI, is very mature. So recently, NVIDIA has launched their NeMo framework, which is very good for these ethical AI one principle, right? So definitely there are limitations, but it is not limitation for technology. It is a limitation for human being. What best we can leverage the technology. Any
Thank you,
further
sir.
questions?
Any more questions anyone would like to ask? We have a question. What are the key considerations we have to work on to selection for the best architecture design for any system?
Yeah, so there are some principles definitely, but those are theories, right? Uh, so like our any application should be cost optimized. Okay, it should be aligned with the software principles. When I'm talking with software principle, whatever the tech stack it is going to consider for the development, those all tech stack, which includes your infrastructure side components, your software side components, means hardware side components and software side components, right? Those all align with the best practices on their fields. If I'm saying Python, so Python should be syntactically best practices has been given with a PET 8 standard that have to be followed when we are programming it. When we are considering any specific compute, so now the topic is our processing, right? We should not be consider something which is ideal, right? So that way cost optimization we are bringing in less, right? And very important thing is whatever solution we are building, it is aligned with business goals, business ROI, business KPIs, right? Then when I'm
Yes.
seeing these things, telling these things, right, it means that whatever solutioning it is follow the best practices for all individual areas. Okay, and definitely architect is one of the highest kind of technical role which any technical vertical is having. So directly nobody can become architects. They have to work with different areas. He have to understand different work. He should understand other technologies as a secondary skill, and then he can play as an architect role.
Thank you, sir, for that incredibly insightful and engaging presentation. We truly appreciate the depth
It
of
is not
knowledge.
completed, right? Now I have to
Oh.
show architecture.
So,
Yes,
Okay.
yes. Please
So-
proceed with the architecture.
How much time we do have?
No. We have sufficient time. You can
Okay.
take it
Yeah.
to the 9 o'clock. No issue.
Okay, perfect. So guys, you are not
Sorry for
getting
interrupting
bored,
you, sir.
right? You're not getting bored, right?
No, sir, I'm really sorry for interrupting you.
No. Deepanjali is saying, okay, it's enough for today. Huh? Okay. Jokes apart. Let me now concentrate towards the architecture. So two architecture I have created. One is just a simple vanilla based on the yesterday topic. Another one is my real-time exposure. Let me, I think, okay. So I'll not jump with the farming architecture. I will directly jump with the real-time architecture. Okay. So this way, this architecture look like. Just think these as a Flipkart or Amazon architecture. In background, these all components are there, and many is not there because of compliance. I am not able to disclose those all. But whatever I can disclose, I am disclosing. Okay, and this is not for Flipkart or Amazon. Just I have for mimic your understanding. I am giving those examples. Okay. So this is the architecture, which is hybrid architecture. It is having 3 core architecture principle, considering on complete designing. First one is microservice based architecture. Second one is n layer architecture. Third one is event driven architecture, and fourth one is data engineering best practices we have considered for this. Okay. Now let me show you the all layers. I'm zooming in. Let me know if you are able to read it out. You are able to, right? Okay. Can someone confirm? Are you able to read?
Sir,
It is readable. Yeah, readable.
It's
So
visible.
I have zoom in, okay? Now I will show
Yes,
you
sir.
all the 7 to 8 layers which I have designed for this solution. AI governance layer. So you all are very concerned. AI is capable enough or not, right? So these all components we are, considering in our architecture so that AI is responsible. AI is follow all the compliance, that is GDPR, HIPAA and all. Okay, it is aligned with what for it has been developed. Okay, it will not deviates its reasoning capability. Okay, so these all things we are considering. I will not go on the components. It will take approx 3 to 4 hours to cover all the components. But yeah, in high level, this is what. Now, so okay, I will map the role also. So this is a AI architect responsibility. AI architect always is having something 10 to 15 members, which belongs senior data scientists, lead data scientists, machine learning engineers, GenAI engineers, MLOps engineers, and he is going to train them before actual development so that they will align with the compliance and governance aspects. Okay. And if they are unable to do it, we have to do a POCs and make accelerators and provide them so that they can integrate it. Okay. So this is the AI architect responsibility. Now, data layer. So this is the data architect responsibility. Again, they are having some 10 to 15 guys, depends on the team, maybe 2 to 3 also in the mid capacity team. And here going to design the data layer. So one example I have given, right? There are multiple source systems, right? So here you are saying SAP, CRM, their own custom, right? Application.
So sorry to interrupt you,
Yeah.
but is it just this page or is there any slide? Because we
No.
are only able to see the Databricks page.
Oh, sorry. It means that you are unable to see that. Okay, let me
Yes,
again
sir.
reshare my screen.
Thank you, sir.
Are you able to see my screen now?
Yes, sir, it's visible now.
That is not relevant then. What I was talking. Okay. So see, this is what the architecture. Can you see?
But you need to zoom it.
Yeah. But overall, you are
So
able
we
to see,
can
right?
Yes,
see
sir,
it.
we are able to see.
Yeah, right. It's a
Yeah,
correct screen.
So first you will see it as a bird view. Okay. So just assume you are 360 feet above of the earth and you are seeing this complete architecture. Okay. Where all the colors, it represent one layer. Okay. There are 7 to 8 layers in complete architecture. Okay. So let me zoom in now. Are you able to see now this zoom in screen where AI governance layer is showing?
Yes.
Yes, sir.
Now
It's
we
visible.
can.
Perfect. So this is what I was explaining, AI governance layer, where all the responsible things, which is compliance with HIPAA, GDPR, which will make sure that fairness is there, no bias should be there, right? Latency and compliances is aligned with what the local governance government has been applied, right? So those all things has been taken care as part of this. So we are listening sometime, right? This application data is storing in China because it's a China app, right? So those all things is going to control with help of combination of this AI ethical layer and the data layer. Okay. There are these all components which is giving its specialized enablement for those application in terms of compliance and governance. But I cannot be covered those all components. It will take 3 to 4 hours to me. So in high level, I covered, okay, what is the responsibilities? Okay. Now, data layer, right? So these data layer, the responsibility is for data architects. Okay, so data architects is having own team where data engineers, SQL developers, those all a member of team, and they are seeing the sources. So as I said, as part of presentation, right, there are ERP, CRM, and other application where the RDBMS kind of data like HANA, Oracle, DB2, SQL Server, MySQL Server, right? Those all are there, and actual data is present over there, right? And then 2 pipelines I have discussed. One is batch pipeline. So below you are seeing, right, batch injection, right? So this is what the batch pipeline. And above you are seeing real-time event, right? So it is a real-time pipeline. So one question came yesterday, how real-time pipeline is going to execute, right? So for that, first thing is producer consumer concept is there. So producer is what? Which is producing the data continuously. And consumer is what? Which is receiving that data continuously. And this is a event-driven architecture-based methodology and process. Okay, so Event Hub, it is a Azure one service which is acting as a middleman for producer and consumer. Okay, so producer is what? When I'm in Flipkart application and I'm clicking something, I'm seeing some pages, I'm seeing some product, I have added something in my cart, right? So that is what the events, that is what the data is going to generate by the user, that is going to consume by this Event Hub as a middle kind of bridge kind of capability. And then it is going to pass via the Redis, that is a queuing system. So there are many queuing systems. Redis I have taken because Azure one service is Redis, which is consuming these outcomes. It is storing that outcome in real time with very millisecond of the latency. Okay, then AKS come to the picture. So again, it is a buzzword, Kubernetes, right? So Azure Kubernetes services, that comes to the picture, which is having processing power. So in here, the processing power, what? The GPU enabled processing power. And on GPU, it is a hardware, right? So on top of that, what we have to enable it? We have to use the rapid base library enablement, right? And then the data is going and say on the Cosmos DB. So another database comes to the picture, right? So from here to here, there are two databases involved. One is Redis, that is a low latency database. And here it is a Cosmos DB, which is more latency compared to Redis, but also it is in the seconds. Okay. And then it is going on the feature store. So this is feature store, which is a core data layer for further ML and GenAI based layers where models are present, right? Any questions till here?
No, sir. It was just noise.
Okay. So till here, so this is what the real-time injection is happening. Okay, and it is event driven. So any point of time, Flipkart kind of application is having 1 million to 2 million kind of active users, and this pipeline is observing and recording all the behaviors these 1 million users are doing. Okay. Now batch processing. So within 5 minutes interval, within 3 minute interval, this complete pipeline, which is real-time pipeline. So in all layer, you will see the interaction with the real-time pipeline, right? So within 3 minutes to 4 minutes, this pipeline is going to recommend, going to distribute coupon, going to do a campaign, right? Going to do cross-scale, up-scale recommendations. Okay. When I'm saying cross-scale means if mobile purchase, supplementary items are going to suggest, right? Charger and all. When I am saying upscale means if you have purchase Apple 15, it will say no, there are some good deal with Apple 15 Pro, go with it, right? With some coupon, right? So if normal pricing in 1 lakh, just go with 10% discount. So that those all things is happening within 3 minutes. Because if user will leave the site, right, then no need, no importance for that recommendation, real-time recommendation, right? He will go to Amazon and he will purchase from there. So within this time, it have to be process complete analytics. Then batch processing within 24 hours, low kind of analysis, which is not that much critical, is going to process with this, and it is cheaper pipeline compared to real-time pipeline. So here the Databricks concept, PySpark concept, Spark cluster concept comes to the picture. If you will see this, so this data layer is completed. Okay. Now feature layer. So data layer. Sorry. You are able to see the feature layer right now in the screen?
Yes.
Okay. So these data layer is the responsibility of data architect, and AI ML architects are working with him closely. Now from here, AI architect again comes to the picture. So whatever inside the Medallion architecture, which is a kind of best architecture for data engineers, data architects, that are bringing the data from, those are RDBMS and SAP and other systems till gold layer. Okay, and from gold layer, we are going to consume as a AI architects, and we are crafting our features. So whatever features data pipeline is bringing and data architects are bringing, there are definitely some fine-tuned data. But on top of that, we are going to do a pre-processing. So there are many pre-processing concepts, like, we have to craft the RFM feature, behavior feature, engagement metrics. We are going to deal with these churn related features. We are going to analyze the customer lifetime stages. So those are features we are going to process, means crafting. So as a programming, we are crafting it on top of that data. Okay, so this is the feature layer. So this is a third layer, what I have explained. Now, fourth layer. So fourth layer is classical ML layer. So classical machine learning models, scikit-learn based, whatever, random forest, right? There is XGBoost, there is linear regression, logistic regression, SVM. Those all models we can use here with statistical model. So statistical model also plays very critical role. So as a mentors, you can bring your students till that statistical model, and post that it is completely opportunity, right? So as part of statistical model, what all things you can cover as your study, like, what is Gaussian distribution, what is binomial distribution, what is probabilistic theorems, what is basic things like matrix factorization, what is differentiation, and these are terminologies you already teaching to them, but relate it with the real concepts. Okay, if differentiation we are doing, what LLMs and neural network we do have, right? So that is working on back propagation concept, which is driven from differentiation. So what differentiation calculation we are doing now, those all things is happening programmatically way on the neural network, which is a backbone for transformer, and transformer is a backbone for LLMs. So ultimately LLMs is coming from you as a mentor, what you are delivering to the students. So that way, if you will explain, it will easy for them to upskill and relate it with the latest technologies, right? So here as a ML layer, those all things those are models we are considering. And here also, if you can see, right, here are two model layers I do have. One is batch model layer and one is real ML layer. So whatever real time pipeline is bringing the data, it is going to proceed with these. And for inferencing, we are using GPU in this section. But when the batch level data is coming, which for 24 hours I do have, I'm going to proceed with Spark cluster, which is a cluster of CPUs with PySpark capability, right? So this is a difference. So till now, you had seen many places the computer scheme, which is a topic for me today, right? And I'm relating it with that topic, right? Now, model inference. So again here, these real-time inferencing and batch inferencing. So from very start, when the AI architecting layer you are seeing as a feature store, where that is bringing a real-time data, real-time path is completely different. And this real-time path is responsible to give the recommendation, coupon, all promotions within 3 to 4 minutes. And whatever the batch side recommendation, everything, this responsibility is to give the recommendation, everything within 24 hours. So data volume also differ. Here in real time, only at a time, whatever active customer is going to process, which is something around 1 million to 2 million in Flipkart and Amazon case, right? For which the data is something around 500 GB to 1 TB, right? Or sometime high in a big billion days and all. But when the batch is, so it is dealing with 1 TB, 2 TB data. But when the batch comes, 1.5 to 2 million of customer into 24, means 24 million customer data. It means 24 TB data, right? It is going to process, right? So that is the difference. And now our favorite GenAI comes to the picture, right? where multiple agents you are seeing, like segment property agent, next best action, customer churn, LTV. So these are all the technical terms. You are no need to worry. This is specialized agent. So like, I'm a very good in AI, right? My dear friend Raju is very good in teaching, right? Vinith is very good in presentation, right? So I will create one agent with specialized capabilities, and that way a complete framework is going to build, which is the best out of we all three, right? So that's why I said there is no limit, there is no limitations. If 1,000 members who is specialized on their fields, right, they are unable to do with a best coordination. But when I will create 1,000 agents with those all specialized capabilities, right, then it is far better, 1,000 times better what one individual can deliver, right? So that is the power of agentic AI. And then API gateway. So it is an infrastructure layer which is taking care all the infra parts, okay, and it is a responsibility for infrastructure architect. If Azure Cloud, it is Azure Cloud Infrastructure Architect, which is saying sometimes system and network architecture admin responsibilities are taking care of it. And the last layer, it is a presentation layer where we as an end user are seeing, okay, this recommendation is coming, that offer is coming, okay, this coupon 500 off is coming, and in background this complete process, end-to-end process is happening, okay. And very important thing, which is, as a fresher, when you are delivering the lectures, you can tell to your students, that is our MLOps CI/CD layer. So see, there are no major difference. DevOps is a buzzword. MLOps is a enhancement on the DevOps. LLMOps is further advancement on the MLOps. So DevOps best principles, which is enabling continuous integration, continuous delivery, version control with repos, right? And there are levels, level 0, level 1, level 2, level 3 maturities, right? So based on that, they have to be automate complete end-to-end thing. So if tomorrow Flipkart will say, hey guys, I want this specific rule is going to, apply in complete product category. So some specific module on those 1 million line of code, some 2 to 3 lines we have to change. And when the complete integration till now, whatever components I have showed, those all get reflect and sync with this change, right? So just it is one click away. Within 30 minutes, a complete system is going to upgrade. Okay, so this is the power of DevOps. So when I was saying as a mentor, you can broadcast this message to your students saying, okay, learn DevOps, because DevOps is a core. Okay, and if they are thinking for some good position, right, in terms of technical or CTO or whatever, head of AI or head of air industry for their specific areas, right, this all concepts come together and become and helping them to become that specific area specialist, right? So yeah, again, as always, open for question and answers.
Audience, so you have any questions, please ask. You may write in the chat box also.
Is there anyone who would like to ask the question? We're waiting for you.
So I'm having surprise for professors. Okay. So if there is no question, I can go ahead. Else just waiting for another 30 seconds for questions.
Sir, is there is question?
Yeah, please.
Question is
Is there any? Neither you go on.
yeah. Question is there any specific mechanism to implement pipeline and to handle data quality?
Yeah, that is. So there are frameworks basically to handle a data quality, and that category comes as a governance, data governance. Okay, so a pipeline, what I was showing here, right? Here, as part of this section, when the raw data come and it is transformed with the bronze layer, that data quality, data lineage, PII data, which is a personal identification numbers and all, right? Those are going to mask, okay, as part of standard governance process. So yeah, this pipeline is handling it.
So there is another question. Any resources for learning DevOps?
Yeah, so Udemy is the best resource, okay? And there is definitely like Udemy is not capable enough to handle everything. So for that, a person who is having expertise towards industry, if you get those guys as a trainer, right? Definitely many professionals are doing freelancing with participating towards the yeah, specific departments and all, and some independent trainers also. So you can form a batch and you can just train with them with 1 to 2 months or whatever the programs are, and you can get a similar real-time understanding. Because see, I could understand when I started my career from 2015, in my mind, it was like, okay, I want to become a data scientist, okay, a lead data scientist, okay. And when I have gone through approx 1,000 plus hour of content from Udemy and other resources, and post that, I have gone through approx 4 to 5 trainers who is teaching. What I have found, they are not having industry expertise and they are unable to deliver the things. So within 2 to 3 days, I was leaving those classes, right? And then I have decided, okay, let me do some certification and all, and cross skill inside the organization itself. And with work, I came to know what actually it is, right? So starting my two projects approx, it was a very bad experience for me, right? And then I advancing on those learnings, which for I have failed and then groomed, right? So that way I have upskilled myself. So definitely base understanding you should be get it from the forums, public forums, Udemy and all. And once you do have understanding, conceptual understanding, okay, what this terminology is, what that is, and blah blah blah, right? Then scenario based understanding, for you should be connect with some good trainer, not those who is not got job in IT and because of sake of understanding they are teaching, but those who are actually having freelancing and doing a real hands-on for the projects. Any further
There's
questions?
another question in the chat box.
Yeah.
If I'm building an agentic AI application using Python and LangChain on my laptop through VS Code, what would be more practical and cost effective, investing in a laptop with GPU or using cloud platforms like Databricks? In
Okay, quickly.
real world development, which
Mhm.
option makes more financial sense for beginners or individual developers?
Okay. Let me quickly show you in real time what all components you should be used. Let me share my screen. Are you able to see my screen?
Yes, sir, it's visible.
Yeah. So this is LM Studio, okay? LM Studio. Just search in Google, you will get a LM Studio link. This is what the application, okay? And in local system, you can install it, okay? And then there are some models like 7 billion, 6.9 billion, 4 billion models, right? This is a gamma models and all that you can install, okay? And then you can start it, and then endpoint it is giving that you have to use, that's it. And then you have to just consume this endpoint. So latency is there, definitely 1 to 2 minutes latency is there to respond by this, but it is behaving the similar what GPT-4o and paid models are doing. So this is one way. Another way is the Databricks. So you all guys will get Databricks free credentials that you can use. Once you are something, pass 1 to 2 months with these all basic tools and techniques, you can use GCP, which is giving 3 months trial-based subscription with all the feature enablement. Okay. Once 3 months is passed, then you do have Azure, which is giving 1 month free trial. Credit card is required, but and that is giving 26,000. And for students, something 1 year it is free. So just put student verification, and you will get one year free services over there. Same for AWS. So this is what the approach should be.
Okay, thank you, sir. So these were the questions.
So
Okay.
now
Let's proceed for both of things.
yeah. So time for surprise right now.
Yes, please.
Please.
Okay. Let me share again my screen. Okay. So surprise is my LinkedIn profile. Okay. So here, if you can see, you all belongs to the, you are masters in theory. Okay. Nobody can beat. Okay. So these kind of opportunity you are seeing here, right? Where Orange House, that is one of the known brand for publishing industry, right? They comes to you. If not, they definitely comes to me. If you are interested, kindly create a good profile in LinkedIn. Okay, they comes to you and they will ask for contribution. Okay, where these kind of opportunities come, where LRU they can give to you, where complete book you can publish, or you can contribute towards some areas review. Okay. And that way you can contribute to public with your theoretical geniusness, right? So this is what I want to show. And whoever is interested, this kind of requirement comes to me frequently, and the reason is because I'm active in LinkedIn. I do have 10K subscribers. Okay. I have Tech Talk kind of sessions with Google, Microsoft, Roundtable, and all as part of my organization sponsor and binding with them, partner agreement, and those always. So if you guys are interested, then please connect with Raju again, and whoever interested, we can, I can, till whatever extent I can help, I will help.
Oh, no, so nice of you, sir. Definitely would like to listen more.
Yeah, thanks.
And definitely
thanks.
get connected soon. So all the audience, all are whosoever is interested, please may connect to.
Yeah.
Okay. Thank
Sure.
you, sir.
So
we will-
if, yeah,
Yes,
please proceed further, Vinit. Yeah, I have done for the day. Yeah.
Okay, sir. So we will proceed for the vote of thanks today. And thank you for this really wonderful session over all these terms. Okay, so I would like to invite Mr. Ganesh Jadonji for the vote of thanks.
A very good evening to everyone. It is my privilege to propose the vote of thanks for this highly insightful session. On behalf of the organizing committee, I, Ganesh Jadon, extended our sincere gratitude to our esteemed speaker, Mr. Vishal Sahare, Generative AI Architect, TCS Pune. Mr. Sahare, your engaging presentation on redefined computer architecture or AI and ML application was extremely relevant and added immense practical value to our FDP. It's perfectly reflected the core theme of FDP. The knowledge of shared by sir will inspire our participant in their research and development activity in their domain. The clarity of his explanation and the practical examples shared have offered valuable knowledge to all participants. Finally, a big thank to all the participants for your active presence and thoughtful interactions. Thank you once again, sir.
Thank you.
Uh,
Thank you, Ganesh sir.
Thank you,
so much.
thank you,
Thank
thank you,
you, sir.
Vishal, for accepting my request. And I definitely, I have to extend my gratitude, gratitude towards you. Your both sessions are wonderful, and use we can say that it's quite engaging, and I'm very sure all the participants definitely get benefit by your lecture, by your both sessions. Thank you so much, Vishal. Thank
Thank
you.
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 Thank you. Thank you, Raju bhai. Oh, thank
See
you.
you soon.
Bye.
Okay, thank you.
Thank you
Participants,
so
it
much,
is
sir. Please, participants, please remember that the feedback
Thank you so
link
much,
is
sir.
shared in the chat box. At the end of the today's program, kindly fill it by tonight and submit it. Feedback is mandatory for attendance purpose. If you do not submit the feedback, you will be considered absent. Our ninth session will start at 6 p.m. tomorrow, so I kindly request everyone to join 10 minutes earlier. Thank you all once again and have a great evening. Good night.